I'd like to discuss the formation of ice sheets and valley glaciers. An ice sheet, if you have your land and you start to accumulate snow in one spot and it doesn't melt, it continues to get thicker and thicker until it gets so thick that it actually starts to flow under its own weight. And ice actually does flow, and essentially you get a land-based, and this is the key to an ice sheet, it's a land-based ground mass. You cannot form glaciers in the ocean, and they tend to be continental land masses. So this is an ice sheet, and it can flow on flat on flat topography because of its size. Now, a valley glacier is a little bit different because here you've got your land surface and you've got ice accumulating in the, let's see here, you've got ice accumulating in the mountains, and it starts to flow downhill, not because it gets so thick, but because it's fairly steep. You get typically a few tens of meters of ice. It starts to flow downhill, and you get a glacier that essentially acts as a conveyor belt. It has two parts. The upper part where the ice is not melting and accumulating, we call that the accumulation area. We have the lower part, that is the area of melting, which we call the ablation area. And we've got this line between them that we call the equilibrium line, which is the zone where accumulation and ablation are exactly matched. Of course, at the toe of the glacier, you then at the toes and the edge of the glacier is where you drop all your sediment in the form of glacial till that we call a moraine, or we have calving of icebergs. That's essentially removing or ablating the ablation area, so you have accumulation at the top of a glacier, ablation or melting at the bottom of a glacier. Where it melts, it drops all its sediment to form the terminal and lateral moraines. These are just a few of the things that we learned today in class that hopefully you will be prepared to answer on quiz number 7 and the final exam.